Okay, linear and nonlinear regression. So what we want to be able to do by the end of today is use technology to fit an appropriate line or curve of best fit to a set of data. And we're going to go through some examples where we use Excel to fit some lines and some curves to some data sets. Then we want to be able to use this equation of line or best fit or curve of best fit as appropriate to make some predictions or answer some questions about the data. And along the way, we're going to look at this thing called the coefficient of determination, capital R squared. And we're going to look and see what that is. Okay. So let's just compare what we're doing today with what we did yesterday. So yesterday, we were looking at this thing that we've seen over here on the left, what we called correlation. So we took our data, and in this case, they've got mortality and latitude, and we plotted one variable against the other variable in a scatter plot, and we were checking to see if the data were correlated, if there was a relationship between them. So we just looked to see if there's a trend, and if we looked at this one here, we would say that there is a negative correlation between the two of them, and then we estimated the strength of it using the correlation coefficient. In this case, they give the value of negative 0.82. So this is a reasonably strong negative correlation. What we want to do today is something a little bit further, what is called regression. Okay, and in regression, we are taking this and we are what we want to do today is we want to talk about regression. And what we're doing in regression is we are fitting a very specific line or curve with a specific equation to the set of data. So rather than just saying that that mortality data and that latitude data are correlated, those two variables are correlated, what they're saying is that they have a very specific linear relationship, that mortality is 389.2 minus 5.95 times the latitude. And we can do that with a linear relationship, or as you see in the graph down at the bottom here, we could do a nonlinear relationship. Because that data there in that graph at the bottom, that relationship between x and y isn't well fit by a straight line, but it's better fit by a particular curve like that. So we're going to look at how to do both of those kinds of fitting in Excel. And as we do this, what we're going to be looking at is this thing called the coefficient of determination, or capital R squared. Now, the coefficient of determination is a measurement of how well that particular line or that particular curve of best fit matches the data value. Okay, so it's specific to the model that we have chosen to fit to the data. Values range from 0, which would indicate a very, very poor fit, to a value of 1, which would indicate that the model perfectly fits the data. And if we want to compare this to what we did yesterday, for linear models, that linear correlation coefficient that we looked at yesterday, that R, if we take that R value and we square it, we get the value of R squared that we get from, that is our coefficient of determination. So R squared is the value that most spreadsheet programs will spit out when you fit a particular model to your data. So you can take that value of capital R squared, take the square root, and get the value of that linear correlation coefficient for your linear model. Just remember that this value of R here applies only for linear models. So small letter r is only for linear correlation, whereas this value of R squared can be for any type of model that we want. Okay. All right, so what we're going to do is we're going to move and we're going to take a look at some examples here. So we've got some data on Canadian population over time and births and deaths. We are going to do some things with it that are going to involve making some scatter plots and fitting some data to, fitting some models to them. So we're going to make a time series graph of the population versus time. We're going to fit a model to it. We're going to determine the R squared value, and we're going to use that model to make predictions. We're going to predict Canada's population in 2019, and then compare it to what we know the actual value is, which is about 37.59 million. Then we've got some information on deaths and infant deaths in Canada over time. We're going to do a little bit more in-depth analysis here. So we're going to look at this data and try to identify the key trend in the infant death data and then fit a model to it, and use that model to predict the number of infant deaths that we would expect from that model in 2018, and compare it to the actual number, which was for 2018, which was 1,750 deaths. Okay, so that's where we're going. So if you've got Excel, now's the time